Now we need to express the decimal number 812.25 in base 10 as firstly a binary number and then a hexadecimal number. So just recalling, a binary number are two-digit numbers taking form of zeros and ones, whilst hexadecimal is a 16-digit number taking values from 0, 1, 2 all the way to 9, and then after 9 we don't say 10, 11, 12, we use the alphabet layer. So we start from A, then we go B, C, D. So the way it works, it goes to 16. So A can represent the 10th digit, so 10, 11, 12, 13. And imagine this as 14, 15, and 15. And that's it. And this represents 16 digits, yeah? Remember, 0 is a digit too, so that's the first, second, third, and so on. So 9, 10, 11, 12, 13, 14, 15. So this is what we use to represent our figures. So let's do the first one first. Let's express the decimal number as a binary. Now, the way this works, we need to work with firstly the whole number part, and then next we work with the fractional part, the 0.25. So let's do this in steps. So working with the whole number first, so let's start with 812. Doing the same method, we need to divide and go, okay? And find the remainders. So dividing 812 by 2, you should get 406 with no remainder. So we can make this in the table again if you like. And then you pull the number down, divide this by 2, you get 203 with no remainder. And then once again, dividing that by 2, you should get 101.5, or in this case, if you get in your calculator, you should get a result like this or like that. Again, use the mixed fraction and the remainder is 1. Now put this number back, so 101 divided by 2. Always do this in your calculator to be safe, and you get 50.5. So 50 with one remainder, put 50 there. Half of 50 is 25, no remainder. Half of 25 is 12.5, so 12 with a single remainder. 12 becomes 6, no remainder. 6 becomes 3, no remainder. And just continue on this side here. Let me change the color pen. So we're on 3. Half of 3 is 1, remainder 1. Half of 1 is 0, remainder 1. And that's it. And like the previous one, we start backwards. So we start from the very last digit and work our way upwards. So we start from here going up all the way back to the center. That's it. So we're going to have basically a binary digit of a solution being 1 1 0 0 1 0 1 1 0 0. So now we've done the first part. Now we need to work out what the decimal bit is. So the digits over here. To do this, we need to consider 25, and instead of dividing by 2, we're going to start multiplying by 2. So let's just pull out the 0.25 here for a second. Okay, the first thing you want to do here is multiply this by 2. And what do we get? We get 0.5. And notice how we only take the whole number part, so we just take the 0. Just like this one, you have a remainder of zeros and ones. We're just going to take the whole part, the zeros here, until we finally get a whole number. So now let's take 0.5 across, multiply that by 2 again, and you should get 1. And now we stop. Why? Because we finally have a whole number. And that's it. And this would be our result. And unlike the previous one, this one we take it downwards. Because if you think about it, if you continue to go up, you're going to land towards the decimal number. So this will cycle into the decimals. So the final result will be the same one and 0, 1. Done. Okay, so I've cleaned the page and now let's look at hexadecimal. So same thing applies. So firstly take the 812, so pull it on the side and draw your dotted line. And instead of dividing by 2, like the binary one, we're going to divide this by 16. Okay, that's the difference. Now one thing to note, if you're using like a Casio calculator, your life would be easy because you can convert your final result as a mixed fraction. And that would be very helpful. So what we're going to do, we're going to write the answer as a mixed fraction here, and then take the quotient remainder step by step, yeah? So it'll help you with your calculations. So in your calculator, 812 divided by 16, and then converting to a mixed fraction, you should get exactly 50 3/4. Now, the whole point of this is that we want to we want a remainder in terms of 16, so it has to be a fraction over 16. So we can instantly look at this and say 50 3/4. If we multiply the 3/4 by 4 up and down to raise it to 16, we should get 12 over 16. And this means we're going to have a remainder now of 12. Perfect. We're going to have a look at how we're going to convert this to letters again, yeah? Now, let's take the 50 across it and rinse and repeat. Divide 50 by 16 and change the mixed fraction. You should get 3 and 1/8. So take your time, guys, yeah? Take your time. And as usual, raise 8 to 16 by doubling. So double the fraction, you get 2/16, which is a remainder of 2 here. Lastly, put the 3 here. Now we're at the end, literally. Divided by 16, you're obviously going to get nothing. And a remainder of 3/16 because, well, there's nothing left except remainder 3. So the answer will be 3. And we're done. At least for this bit. So firstly, the 12. How is that written in? So how do we write this again? So the key idea is to firstly convert the number into the acceptable format. And just to recall, hexadecimal takes digits from 0, 1, 2, 3, all the way up to 9. And then after 9, instead of writing 10, we say A, B, C, D, E, and F, where each letter corresponds from 10, 11, 12, all the way up to 15. So F is the 15th. And all of this makes 16 digits for hexadecimal. And oh yeah, so 12 is going to be, let's say 10, 11, 12. So 12 is C. And that means as a hexadecimal number, we look upwards, so it'll be 3 to C. So that's the first half of the answer done. So it'll be 3 to C. Point. Now we need to find the decimal bit, the 0.25. And just like the binary one, well, you just multiply that by 16. So not bad, man, not bad. Just practice. So let's put 0.25 times that by 16. What do we get? You get 4. And you're done. Because you got the whole number, and this is one of the acceptable formats. Remember, it has to be within the acceptable formats to end there. And yeah, leave it there. Done.